Hello everyone, welcome back to this class. Now let's go to the third part of my section, the pavement materials, structural characteristics. The reason we put this as a separate section is that the structural characteristics of these paving materials are very important, and sometimes they may have a great influence on the mechanical properties. So we also need a proper design sometimes. Now let's take a look. Here is the contents of this mini class. Generally, we are going to introduce the structural characteristics of the unbounded granular materials, inorganic brine stabilized materials, the asphalt stabilized materials, asphalt mixtures, and the cement concrete. Now let's take a look one by one. First, unbounded granular materials. Generally, the unbounded granular materials, they may have three basic structures. The first one, void skeleton structure. What's this structure? The skeleton is created through the coarse aggregates interlocking, but the fine aggregates are not enough to fill the voids, like this. So we can see in this picture that those coarse aggregate particles, they interlock with each other, and there are voids inside them, right? The second one, dense skeleton structure. The skeleton is created through coarse aggregates interlocking, and the skeleton air voids are filled by the aggregates, like this one. We can see that the aggregate skeleton is there, however, most of the air voids are filled with fine particles, so we call this dense skeleton structure. The third one, dense continuously graded structure. What's this? The coarse aggregates are not enough to create a skeleton, so they are suspended in the fine aggregates. Like this, we can see clearly that the fine particles, they are a lot, and the coarse particles, they are suspended in the fine particle matrix. So for these three different structures, they may have a very different mechanical performance. And which one we should use, it will be based on the detailed scenarios. About the application of unbounded granular materials in pavement. Generally, the thickness is about 8 to 16 centimeters. If higher than 16 centimeters, we need to construct them by 2 layers. And we also have the recommended gradation for different levels of highways. At the beginning, we mentioned that for the unbounded granular materials, that is graded crushed aggregates or graded gravels, that means we have a required gradation. So this figure, we can see that this is a very common or typical gradation for the unbounded granular materials used in the highway in China. And sometimes if it is an expressway or the lower level highways, the gradation can be a little different. For the inorganic brine stabilized materials, we have 4 basic structures. What are they? The first one, skeleton void. This is similar like the unbounded granular materials. Right? We have the skeleton, but we also have air voids like this. Second one, the dense skeleton. We have the skeleton, but we have very few voids like this. And the dense continuously graded structure. We have the coarse aggregates suspended in the fine aggregates, not enough to create a skeleton like this. And in addition of the 3, we also have the fourth one for the inorganic brine stabilized materials. We call it uniform and dense graded structure. What's it? That is, particles in the structure have similar sizes or dense graded and dense graded, like this. Generally, the uniform and dense graded structure, that is not that widely used as the previous 3, but we also have the application scenarios. About the asphalt stabilized materials and mixtures. And be mindful here, I put the asphalt stabilized materials and the asphalt mixtures together here, because generally these two, they have similar structures. So what are they? 3 basic structures. We can take a quick look because they are very similar as the previous one. The skeleton void, skeleton created through the coarse aggregates, right? And we have the air voids. And we have the skeleton dense structure. We have the suspended dense structure. And we also have notes here. Different from the unbounded granular materials, for the asphalt stabilized materials and mixtures, we have bonds between the particles. These bonds are from the asphalt mastic or the sand mastic. And we also have very few chemical reactions between the different materials, for example, between the asphalt and the aggregate. And the chemical reaction plays a minor role in the mix performance. We may have a little, but the chemical reaction is not that important. How about the cement concrete? Cement concrete, we need to classify them into the plain concrete and reinforced concrete from the lean and rolled concrete. For the plain concrete, we have the gradation is not as important as the other paving materials. Why? Because the cementitious material, the cement itself, is more important than the gradation. If you have already learned the coarse, the roller materials, you will see that in a cement concrete design, the gradation is not that important. And the gradation is dependent on the requirements of strength, working performance, and the durability. And the cement takes even more important roles than the aggregates. For example, the cement type, the cement amount will greatly affect the performance, like the strength, the shrinkage, and the modulus of the concrete. How about the lean and rolled concrete? We know that the lean and rolled concrete is also add some cement on the unbounded granular materials. So the structural properties of the lean and rolled concrete may be similar from the IBSM. Therefore, the 4 structures of the IBSM are still suitable. And the cement contents are as important as the aggregate gradation. So that means we need to take care of both of the aggregate gradation and the cement content. We also have notes here. For example, we also have bonds between the particles. Where are these bonds from? It is from the cement paste. And also the cement curing plays a significant role in determining the mix performance. This is about the cement concrete. And here we show direct comparisons between these materials because we have already talked to them a lot. So what are the main differences between them in terms of the materials and in terms of the structures? We can take a look at here. From the left to the right, we have the unbounded granular materials, and if we add a little bit asphalt inside, so we can get the asphalt treated materials. And if we add more asphalt, we can get the asphalt mixture. And at the bottom, we can see that if we add some inorganic or binding materials, for example, we add cement or we add fly ash or lime, we got the cement stabilized material. And if we add more cement, then we get the lean concrete. And at the very right, if we add more, even more cement, we can get the cement concrete. So from the left to the right, we have generally a trend like this. For example, the bind content, from the left to the right, we will have more and more bind content. And the aggregate size, we generally have smaller size, but this is not a very rigid trend. For example, for the lean concrete, and we could have comparable aggregate size from the unbounded granular materials. This is only a general trend. And about the strength, you can see that from the left to the right, we have higher and higher strength. Of course, the modulus, we can also see that they have higher modulus. And in terms of the application of the layers, we can see that unbounded granular materials, they are used for the subbase or base. And for the cement, concrete, or asphalt mixtures, they can be used for the surface layers. So from left to the right, the application could be from the subbase to base and to the surface course. And of course, one of the most important things is about the cost. From the left to the right, the cost is to be higher and higher, because we know that the asphalt and the cement, their price are higher than aggregate. Okay, I think that's it for the structural characteristics of the paving materials. Thanks for your attention.